Good morning, students. I am Manibhushan Prashant. This is the class for class 10, subject mathematics, and topic similar triangles. Is it clear? Now, we have already discussed in chapter similar triangles about BPT and the problems based on BPT. Today, we are taking for similar triangles. Just see, what are the similar triangles? Two triangles are said to be similar if their angles, corresponding angles are equal and the corresponding sides are proportional. Just see, here triangle ABC and triangle DEF are similar. This is the symbol of similarity. So, what is the property of the similar triangles? Corresponding angles should be equal. So A is equal to D, B is equal to E, and C is equal to F. And the corresponding sides will be proportional. So that we can write here AB by DE is equal to BC by EF is equal to AC by DF. If the triangles will be congruent, on the time you can write AB is equal to DE. Okay. But here these sides are proportional. Okay. Now, these two conditions of similarity, the property of the similar triangles are not independent. Means that anyone, you can prove now that this is called the property of similarity. AAA, all the three angles are equal. And this is known as SSS similarity. So, if AAA is given, we can prove the triangle is similar. That is sufficient. And if SSS is given, sides are proportional given, even then we can prove that triangles are similar. And hence you can get this result. So that these two conditions are independent. Okay. Now let's see. The two triangles can be proved similar. For that there are four different conditions. First, SSS similarity. Second, AAA similarity. And its corollary AA. If the two angles are given equal, automatically third angles will be equal. So that instead of this one, we just try only for AA similarity. And another one is SAS similarity. SAS means two sides are proportional and including angles are also equal. Is it clear? SAS similarity means suppose AB by D is equal to AC by DF and angle A and D included angles. Just say A and D between these two sides. So this is called included angle. Included angles are equal. Okay. Now proof of all these theorems are not asked in your examinations. It is only for your knowledge purpose. Now just say the theorem which will be asked in your examinations. I am going to discuss here. See, it is a very important one. The ratio of the areas of two similar triangles are equal. What it says? The ratio of the areas of two similar triangles are equal to the ratio of the squares of any two corresponding sides. Okay? If you suppose that in triangle ABC and triangle DEF, then you have to prove that area of ABC by area of DF. This is the ratio of area of triangles. That is equal to AB square by DA square or BC square by EF square or AC square by DF square. This ratio is equal to the ratio of squares of any corresponding side. Okay. For this, we will draw perpendicular, AM perpendicular BC, DN perpendicular EF. Okay. Now let's take the proof. If triangles are similar, it is similar is given. So triangles are similar, angles are equal, sides are proportional. We take the ratio of triangles. Let's see, triangle ABC by triangle EF, half into base into height. And so half and half cancel. Now we have taken the ratio of BC by EF. And now this is separate AM by DN. Okay. Now prove the squares. We will try. We will try to prove this AM by DN as equal to BC by EF so that it should be a square. Now just see for AM by DN. No. So we just suppose that triangle APM and triangle DEN will be similar. We will try to prove these two triangles similar. How? Just see, angle B is equal to angle E. It is already given as triangle is similar. Triangle ABC and triangle DEF is similar. So angle B is equal to E. Okay. And angle M is equal to angle N being 90 degree. So in these two triangles we find two angles are equal. So these two triangles will be also similar. Okay. By AA similarity. Just see, the two angles are equal, so triangle is similar by AA similarity. If triangles are similar, then we can write AB by D is equal to AM by DN. Just see, AB by D is equal to AM by DN. Now, AB by D is equal to BC by EF from the first. Just see, from the first. So, BC by EF is equal to AM by DN. Now, from 2, AM by DN. AM by DN can we put here? And so it becomes BC by EF into BC by EF is equal to BC square by EF square. Is it clear? So that areas of these two triangles becomes, now this is from 1 as the BC by EF, so we can take AB by D square, BC by EF square is equal to AC square by DF square, answer proved. Okay. Now the same. We can take the another problem based on this theorem. See here. Area of two similar triangles are in the ratio of the squares of the corresponding altitudes. Clear? Area of two similar triangles are in the ratio of the squares of the corresponding altitudes. So here we have taken triangle ABC and triangle DF. These two are similar and their altitudes AM and DN. So what I have to prove? That area of ABC by area of DF. This ratio is equal to AM square by DN square. Now proof is quite easy. Just see. We have taken that triangles are similar. It is given. So that this ratio should be equal to AB square by DA square. AB square by DA square. Now what left? If we just prove that AB by D is equal to AM by DN. No. So that for this purpose, it requires to proving these two triangles are similar. Okay. In the same way, we can prove now. Just see B is equal to E and M is equal to N being 90 degree. And so the triangle will be similar. And if similar, then AB by D is equal to AM by DN. Now put this here so that you can get your result. Okay. AB by D is equal to AM by DN, where as these two small triangles are similar, and so their squares will be also similar. Okay, and now put this result in the first, so you find AM square by DN square. Okay, take the another one. It is also very good questions. It is already given in your board examinations. See here, prove that the area of the equilateral triangle described on the side of a square is half the area of the equilateral triangle described on its diagonal. I mean, if you take the square ABCD and draw equilateral triangles on diagonal, just say BDE and one equilateral triangles BCF. Okay, you can draw this triangle on any sides, no problem. So I have drawn on basic. What I have to prove then? I have to prove that area of BCF, sorry, it should be BCE. Okay, it should be BCE is equal to BC. Oh, it is quite correct, no problem. Just say area of BCF is equal to half of BDE. Okay, BCF is equal to half of BDE. I have to prove. Now just say that these two triangles are similar. Why? As equilateral triangles. Both are equilateral triangles. So BCF by BD, what will happen? Take the corresponding sides. BC square by BD square. No. triangles are similar, so their ratio should be equal to squares of corresponding sides. So BC square by BD square. Now what is the BC? BC is the side and BD is the diagonal. But we know that in a square, diagonal is root 2 into side. So that this BD can be written as root 2 into BC. So BC square by 2 BC square. BC square cancels, it is half, and hence we can write area of BCF is equal to area of BDE. Clear? Okay, friends. Now we take one more problem. See now. It is also a good question. Just see. Equilateral triangles are drawn on the sides of a right triangle. You see, this is I have taken right triangle ABC, and on all each side we have drawn in equilateral triangles. I mean APB, BCQ, and ACR. All these three are equilateral triangles. It says that so that the area of the triangle on the hypotenuse, is equal to the sum of the area of the triangles on the other two sides. I mean, I have to prove that area of ACR is equal to area of APB plus area of BC. Okay? I mean, equilateral triangles on hypotenuse is equal to that area of APB plus area of BCQ. For this purpose, just see the proof. Keep in your mind that it is a right triangle, so that you know very well that AC square is equal to AB square plus BC square. We will use this result. No. Now just see, all these three triangles are equilateral triangles, though all of them will be similar to each other. No. So area of APB is similar to area of BQC. Sorry, triangle APB is similar to triangle BQC, similar to triangle ACR. If they are similar, so that we can take the ratios of their area. So I am taking APB and ACR, and here BQC and ACR. So what will be is this result? It will be equal to AB square by AC square, and for this one BC square by AC square. Clear? Now you can take the ratio LCM AC square. Here it should be AB square plus BC square. But you know very well that AB square plus BC square is equal to AC square. So AC square by AC square it is 1. And now so that in this side also you have taken the LCM. No. Denominator is same ACR, and so it is APB plus BQC. Hence this ACR should be here. No. So that area of ABB plus area of BQC is equal to area of ACR. Clear? Do practice for this one. Now this is one numerical problems. It is very small problems. It may be asked in 1 marks. Just see. For this figure, it says that AQ is perpendicular and PB is also perpendicular. And the data are given that AO is 10 centimeter, BO is 6 centimeter, PB is 9 centimeter. We have to find AQ. So at first we will prove that these two triangles will be similar. Now it is quite easy. Just see angle O barabar angle O, no, and A barabar B as it is 90. So that I have mentioned here A is equal to B 90 degree, and angle AOQ is equal to angle BOP, vertical opposite angles. So that these two triangles, I mean AOQ and BOP, will be similar by A similarity. Take their ratios. AQ by, just see AQ by BP. This will be equal to AO by BO. Be careful for taking the ratios. Okay. Now put the values. AQ by 9 is equal to 10 by 6. So AQ will be 10 into 9 by 6. Now you can cancel. You can get the result. AQ is equal to 15 centimeter. Is it clear? So in this way you can solve so many problems from your textbooks, and you will be able to solve this one. Okay. So I just hope that you will do more practice and you can post your solutions. Thank you. Have a nice day.